Can you hear me? Yeah, I'm dressed like liquidity boss today. We're gonna talk about liquidity protocols, yeah? So you know a little bit about it, yeah? So yeah, because I was previously talking to developers and some of them were like experienced liquidity providers a little bit. So I would assume you are liquidity providers, yeah? Or you're also developers? Who's yeah, liquidity providers. Okay. Yeah, and who are protocol engineers here? Okay, that's good. So you combine this like understanding and earnings, yeah? Okay. Okay, I'm happy to be here with my favorite community of liquidity providers. Finally. So I cooked some presentation where I explain a new concept of liquidity provisioning. So yeah, let's just get started. Okay. So yeah, I would start with the question, what is capital efficiency? So I read some papers. Actually, there are more than 50 research papers analyzing capital efficiency of different liquidity provision solutions for market makers. So yeah, actually a lot of them define it differently. Some of them state that capital efficiency is ability to attract volumes per capital. Some of them state it's ability to earn fees per capital. Sometimes it's yield per capital. Sometimes they operate capital liquidity wording. So yeah, it's pretty wild and pretty different. There are like more popular papers, less popular papers. So reading some of them, I understood that I do not understand what is capital efficiency. So yeah, it's complete mess for me. So I tried to understand what I can spot as inefficiency on this market and how we can to address it. So the very first thing we did, we analyzed how much of liquidity is not being moved. It's being idle in the pools. It's just sitting there. Is it doing something? So for the 90% of the days in this year, Uniswap v2 had 95% of liquidity sitting idle and is not participating in swaps. So yeah, in the rest, like in a few days per year, it's probably participating more. So we have a cool dashboard where you can see this in detail per percentiles, like super detailed. And all those SQL queries are there, yeah. So what this liquidity is actually doing there? Why it's still there? It's definitely contributing to a price curve. So prices are being computed based on those amounts. But it's not being utilized properly. This means that it is not actually earning, because your liquidity is only earning when it's working. And yeah, that's something what I would call one of the inefficiencies of existing approach. If we take a look, we can see something, okay? That current approach is that liquidity providers are providing liquidity into different pools. And if you would try to provide liquidity to tens of different assets, you would end up by fragmenting your liquidity. Your most liquid assets, like stable tokens, wrap Ether, wrap Bitcoin, you would end up splitting them, fragmenting them among different opportunities. And most of them are not very volatile. And yeah, most of your liquidity will stuck there, fragmented, and being underutilized. This is also one of the inefficiencies. And another inefficiency here is that you lock your liquidity. Your liquidity is locked. But what does it mean locked? You can withdraw it any moment, yeah? It's permissionless. You can withdraw it from AMM, yeah. But being locked means that it's limited in its functionality. It means that you can't vote with your governance tokens. You can't participate in V-tokenomics. You can't go to money market with these assets or do something interesting with it. So these three inefficiencies, idleness, fragmentation, and locked capital, that's what we try to address with our new approach. We came up to a better vision, which is not in focus now, where you could not clearly, but you could see that capital is on liquidity provider wallet. It's green, it was open lock, you see, like dollars and open lock. So capital is the LP wallet, and AMMs, they're getting access to this liquidity through this Aqua on demand. Aqua is a shared liquidity layer protocol. Layer means that this is a layer protocol between other protocols and liquidity provider. I would explain how it works on the next slide, but in terms of architecture, it actually providing shared access to the same capital for different AMMs or PMMs. That could be any kind of logic here. And it also unlocks your asset. This means that while they're on your wallet, you could vote in DAO or do any other things. Yeah, let's explore. Yeah. So actually, being liquidity provider, you could use Aqua as following. You have some assets on your wallet. There is underlying rectangle here. Okay. And via Aqua, you could define virtual balances dedicated per strategy. And when taker comes to this AMM to trade, to make a swap, this AMM just checks virtual balances according to the strategy hash, and then compute swap amounts, and then use pull and push methods of Aqua to get access to maker's liquidity. When it's pulling liquidity, balances are being decreased. When it's pushing balances, balances are being incremented. This means that AMM can get full access to your liquidity, and it will try to earn you something with atomic pull and push. Aqua is not actually limiting it to being atomic, but yeah, Aqua can't guarantee those strategies would earn you something because, yeah, there is impermanent loss and other things. So, yeah, AMMs are same dangerous as previously, but now they can get access to shared capital. And this means that you could increase your capital efficiency in different aspects. Okay, so now, when your capital is on your wallet, like the two main aspects of our approach is that your liquidity can be shared and reutilized among different strategies. And second point, that it's being unlocked. And actually, being unlocked means a lot. You could vote in DAO, participate in some tokenomics. You could also leverage your liquidity with money market. I have next slide about this. You could also borrow liquidity on demand from money market when swap is happening. This is possible with advanced AMMs, which could provide you hooks or something like this. So yeah, that's the scheme how you could turn your 10K of bucks into 30K of collateral and 20K of debt. So yeah, 30K minus 20K is still 10K. So economically, this makes sense. I think you all understand how you could spin up this position. There are like two different ways. You could deposit, borrow, put what you borrowed into collateral, borrow more, put again into collateral, borrow more. You could spin up your position. Or you could use flash loans to make it in a more like efficient way. Some money markets would support you with this, some are not. You could use flash loan from third-party provider or something like that. But you could end up to this. Economically, it makes sense. You still have 30K minus 20K. But you just can't withdraw all your collateral because this is like an 8 tokens of an hour or something like that. So you could provide these three assets into three different pairs of AMM. And this would lead you to having 60K of liquidity. But you remember, you came with 10K. You got 3x leverage of liquidity with money market on your own, with your own wallet. You came to Aqua and did it on your own. And then you came to Aqua and got 2x more by just reutilizing the same capital, sharing this capital among multiple strategies. So while you maintain your balances above zero, you would earn yield from all those strategies for all those 60K capital. Yeah, if one of your balances will be drained, yeah, you can probably do like different things. You can stop those strategies and start them again later if you wish. Or if you would get some liquidity back on your wallet, you could face immediate impermanent loss because someone would arbitrage you. Yeah, that's not good, but that's still manageable since it's impermanent. So yeah, but the only tricky thing here is that you couldn't probably swap 10K. If Aqua would try to pull 10K, you will be under collateralized. So transfer of collateralized token would not let you do this. Money market would revert. So yeah, AMM needs some basic support for this case. AMMs should support push and then pull. So they would just increase your collateral first and then decrease it. So it makes sense. But Aqua itself supports this feature with 0 lines of code. So we'll only need to support it on AMM level. What is my next slide? I'm not sure. Okay. Oh, it's too fast. Okay. So yeah, what is capital efficiency? I think we're trying to redefine it. We think that capital efficiency is no more metric of a protocol. It's metric of efforts. It's metric of risk appetite. So you could achieve unlimited capital efficiency. Not infinite, but unlimited, because our protocol is not limiting you, it's empowering you. So there was a concept of toxic flow. I wanted to pay attention to this topic also. Yeah, because some people call it toxic flow and non-toxic flow. Toxic flow is something like arbitrage volumes. I think this is a misconception, and volumes should be separated on two different things. Actually, I call it fair volumes and unfair volumes, where fair volumes are volumes which earned by your protocol, by your position, fairly. This means they are being earned by their prices, their offering, via their strategy. And you get fair share of volumes when someone is trying to distribute volumes fairly to achieve the best taker price, like aggregators. All volumes from aggregators, when they work correctly, they are fairly distributed. If they are unfair, they provide not the best rate. So, and for sure, there are unfair volumes. Unfair volumes is when someone is using unfair competitive advantage. It's like sending volumes from your website to your protocol. We saw this from Uniswap a lot. Like 5 years ago, we saw that their volumes to their protocol were like 4x unfair comparing to the fair volumes. Now it's being more fair because they also launched Uniswap X and resolvers, solvers, all those infrastructure things which are helping takers to get better rate. It's making volumes more fair. And I think that Aqua would give you leverage to get earnings even from arbitrage volume. Let's just imagine you have AMM, you provide some liquidity, price went somewhere, but you got only arbitrage volume. Okay, you have some profits from fees and you have some impermanent loss. And then price got back. Okay, you have more earnings and you have 0 impermanent loss. Okay, you got some earnings from arbitrage volumes. So how you can call it non-profitable? It is profitable. Why you earn? Because you made a job. You was market maker. You was making this market. You was working within some spread. So I think it much more sense is to think about your liquidity position as a spread machine. Your spread machine is moving with the market, with the price, and it's capturing value. It could be flat fee. It could be dynamic fee, depending on how volatile is the market. It could be Dutch auctions selling arbitrage opportunity. I will tell about this later. So, yeah, I think no flow is toxic anymore. So I added really cool phrases here, yeah? Okay. So, yeah, I told almost everything regarding Aqua itself, and the next thing is our approach to build the best AMM out there. But yeah, for sure, we can't be the best AMM which would get everything. We expect competition. We expect tens, hundreds of different AMMs to be built on top of Aqua. And now they can compete without TVL. They can compete with just their logic, their math, their approach. So yeah, we tried to build our own, like a fair play. We did a cool architecture decisions to split our like share liquidity layer for everyone and our own AMM trying to make the best architecture. So what is SwapVM? SwapVM is basically swap virtual machine. But I was asked like multiple times in the past days, what the heck is virtual machine? Is it competition to EVM or Solana VM? Like, is it your own blockchain or something? No, it's just an architecture. This architecture, being virtual machine, means that it should operate something what can be called instructions. This is some kind of programs which can be composed to achieve something more than one program. So it's like program logic composable out of components, models. Okay. Okay. So the first slide actually explains how it works. It's kinda self-explanatory, I would say. If we start from bottom, we would see that one of the instructions is implementing the swap formula. It could be a constant product formula or any other formula you would prefer. Okay, next instruction is flat fee. So you could configure this fee, or you could use different instruction called dynamic fee or like progressive fee, or any other instruction you could develop on your own. There are also instructions to concentrate within some range. If you want to achieve concentrated constant product, okay, just place those instructions one by one and you will have this program which is defining logic of how your position, your liquidity should actually work. And there is a decay spread. Now it's disabled, just for example. But what is decay spread? How many people ever heard about MoneySwap? Oh, few. Okay. Okay, the MoneySwap. Oh, that's better. Thank you. Okay. Okay. So, okay. So the MoneySwap was the thing which we invented like back in 2020 or 2021. I don't really remember. This was the thing that it was like constant product thing, but a little bit different. When someone performs a swap in the back direction became immediately super profitable for arbitrage traders. And we decided that, oh, that's bad. We see how many arbitrage traders earn on this. We counted this. 5 years ago, we counted this for top pools on Uniswap, and we saw that arbitrage traders profits from background the same amount of value which is being earned by liquidity providers. And we said, oh, we can try to fix that. And that's what we tried to do. We actually made it like that. So whenever swap happens, the price in the back direction is not being changed immediately. It's being the same. Meanwhile, it starts shifting gradually to the new place, and arbitrage could start happening earlier. Oh, I actually have a slide about this. Okay. Okay, so yeah, how is this possible to make those instructions work independently from each other and make it like a composable logic? Am I tricking you or not? Is it like a huge mess of code with different ifs and flags? No. We came up to a data model, which is like the core of this architecture. But it's simple as that. It's pair of balances and pair of amounts, where in and out means direction for maker. In means maker would receive it, out means maker would spend it. So balances are like real balances from Aqua. Okay, what are amounts? One of the amounts is being provided by taker. If taker is providing amount in, our instructions have to compute amount out. This is what usually called exact in swap. If taker provided amount out, our instructions have to compute amount in. Okay, that's exact out swap. The thing is that our instructions is like one piece of code each. And it's the same code for quoting, for swapping, for exact in and exact out. For simplification, for sure, because we don't want to write this code 4 times. So I brought you 3 examples of instructions. The very first one and very obvious would be constant product. I think, yeah, you should all know how it works, yeah? Raise your hand if you know how constant product formula working. Okay, but I will explain anyway. While I'm here, you have to listen me. Nadia said this, so yeah. So the thing is that there were all balances, balance in and balance out. You could not clearly, but can see it here. And there will be new balances. Balance in plus amount in and balance out minus amount out. So the formula is simple as that multiplication of product of balances before swap should be equal to the product of the balances after swap. And we can just express amount in and amount out of this expression. And yeah, for sure, ceiling is important. Be careful with rounding, or you would fail as balancer probably. So whenever you compute amounts which would be given to a maker, you would be rather ceiling than flooring. And on the opposite side, when you compute amounts being given out from maker, you would better floor than seal. So yeah, this is pretty simple stuff, yeah? Everyone knows this. There are no fees here, and it makes no sense to have fees here. Fees are a separate instruction. I don't have it in my slides. It's too complicated, guys. Actually, yeah, I'm not kidding. We spent like several days to make it work because it was much more complicated than we originally thought. Because, yeah, all those instructions, they have to like maintain invariants. All those instructions should have, for example, symmetry according to exact in and exact out. You don't want your instruction to give you different exchange rate. So yeah, it's actually a little bit complicated, but it's easy to understand if you would read it with comments. But yeah, I would start with something easier, yeah, like a concentrated liquidity, yeah, for sure. It should be easier than flat fees, yeah? And it is. To concentrate liquidity, the only thing instructions should do is to increase balances by some deltas, which could be computed off-chain. So in smart contract, we have to do only this, just increase balances. That's awesome. But there is one trick here. Your real balances would walk here on this invariant. But why? Because your increased balances work on a real invariant, yeah? Like constant product for real. You can see, but it's like also line here, yeah. And here is like 0 here and 0 here. But trick here is that if you would start collecting fees, you would start. What would happen to this thing? It will actually grow in range. How many of you would be happy to concentrate liquidity in range and see it's growing with fees? At least few of you would be happy with that. Yeah, or you want it strictly maintain range? You want strict? Yeah, okay, but maybe few of you would be happy because this approach is cheaper in terms of gas, yeah, for real. It's like 10K cheaper, yeah. So yeah, if you want to maintain range, okay, we have 2 instructions for this. This instruction is being called XYC concentrate grow price range. But we developed another one, not on the slides, but I will explain. We call it XYC concentrate grow liquidity. What's doing? Right after the swap, it's checking how invariant increased, multiplication of balances, of new balances, divided by multiplication of old balances. That's actually invariant increase. So we should just readjust deltas with this invariant increase. And you would get instruction which would let you to grow your liquidity with fees to after compound your earnings and maintaining the price range. Also pretty easy to understand, comparing to flat fees. And yeah, the MoneySwap thing actually, that's the most complicated stuff now probably. So yeah, I will explain what this visualization means. So we start from here, from this point, and some swap happens to the beginning of the blue line. And then swap in the back direction is not starting from blue, it is starting from here. And within every second, our virtual balances are approaching real balances directly. This is straight line. And at some point, arbitrage is happening. Arbitrage is happening with these virtual balances. And every swap on this chart looks like a walk by invariant. It's invariant, it's not straight line. And this swap is being applied to real balances. And then virtual balances again start to go to real balances. I'll wait a little bit. Yeah, like this. And at some point, arbitrage happens again. And swap happens. And again. And at some point, we end up here with real and virtual balances together. So why we did all this pine tree? Actually, moving balances from here to here is increasing your balances. That's how liquidity providers are actually capturing the value. If you have no fees, you will walk by the same line, by the same invariant. So in this scheme, we see that it's like a Dutch auction, which is selling arbitrage opportunity to competing arbitrage traders. And that's how we saw in the past, when we were running MoneySwap, we saw that we dropped arbitrage trader profits 10 times. And this led us to increase liquidity providers' profits 2 times, almost 2 times. And the thing is that we were happy with that result 5 years ago. But the thing is that Uniswap got 4 times more unfair volumes. This means that their liquidity providers were still earning 2 times more. And that's why we also deceased the project. And one of the reasons was that Uniswap released version 3 with concentrated liquidity. And we said, okay, we can still try to make our approach work with concentrated liquidity. But yeah, this is too complicated. This would take probably 1 year to develop this on top of Uniswap code, which is not even open source. We have to write our own. This is a huge thing to develop, 1,000 lines of code. And yeah, we decided to discontinue our liquidity protocol. But nowadays, we're able to implement this logic as a separate instruction, which is composable with almost any other AMM instruction. This means that we could achieve concentrated liquidity MoneySwap idea with just few lines of code in each instruction by just composing these instructions to each other. So yeah, why is so simple? Because it's a matter of architecture decision to find this data model which suits those composable computation is the whole invention, I would say. So yeah, if you would decide to build your own AMM, your liquidity providers, but you have to understand this thing. Building own AMM starts with an idea that you could provide some cool swap logic. You have a great formula. Yeah, true. But you still have to develop a lot of other supporting stuff. Deposits, withdrawals, balances accounting of like maintaining shares of liquidity providers, swap settlement itself handled correctly. And yeah, for sure, you have code level composability. This means that you can write code, read code, copy code. Yeah, you can do this. But this is like really something huge. And this is like I call it red word, requires. It's requirement. It's bad connotation, you know. And with the SwapVM, it actually empowers you. You see green word, yeah? So you can just develop swap logic within instruction. And if you will just came up how it can be expressed within this data model as instruction, you can avoid writing all this code. You will have instruction level composability. you will be able to compose your unique logic with existing logic which we already developed. We spent some time and developed like almost 30 different instructions. Some of them are useless for debug, or like control instructions like check if taker have some NFT if they're eligible, if you want to make this system like more closed resolver based. This depends on like restrictions based on business logic. But we also have pretty cool instructions dedicated to single directional swaps, like limit order, okay, Dutch auction, okay, swap, DCA. For example, if you would consider what is Dutch auction, we actually came up to a vision that within this data model, it makes sense to have two separate Dutch auctions. You would say, why? Dutch auction is one thing, its price should drop. It should get worse for maker and get better for taker, and takers compete and they come and they swap and that's it, yeah? No, it's not like that. There are two different Dutch auctions. There is Dutch auction where you're trying to sell something, specific amount of something you are selling, and the amount you are getting is being dropped. Okay. But there is another way. When you're trying to buy something with Dutch auction, the amount you're buying is fixed, but the amount you're spending is growing. So that's why we have two different instructions. Imagine someone implementing this thing for NFT marketplace. That's obvious that it's different use cases when you buy NFT or sell NFT. It could be both Dutch auctions, but it couldn't be the same code. It should be like different business logic actually behind this. So yeah. It's already finished. So yeah, I'm happy to answer your questions, guys.
So Rock is the probable guarantee that also pool amounts the residual.
Yeah.
Bonds. It's like there is some shady AMM provides to pull to view and push the mesh.
Yeah.
So how do you
The thing is that pull and push methods, they're affecting those virtual balances. And they're actually making assets move through from and to maker wallet. So originally you dedicate some balances to some specific strategy, and this strategy is allowed to pull all those balances. It can push it back, but Aqua can't guarantee that. So if you would just allocate some balances to some malicious AMM, it could still allow it balances, but Aqua here is actually helping you to restrict those amounts. So yeah, you are controlling the amounts dedicated to each strategy.
Is there any plans for separate equipment for Aqua?
No, not really. We have more plans to develop much greater things in DeFi next year. I mean, you see, I'm like thrilled about this thing, for real, yeah? This is a cool thing, yeah? But I have so much more cool things inside of me which I can't disclose to you right now. I just can only imagine your faces when I will present it to you next year.
What is the major product foundation?
Yeah, I mean, could you imagine, we started with DEX aggregator. So we tried to solve the fragmentation problem for taker, yeah? And now we came from the other side and saw that makers also have fragmentation issue, and we are like, oh, we're gonna solve it. Oh, nice. It will be so defragmented now. But could you imagine fragmentation for takers after this? When each position would be handled separately. Fragmentation will be like really insane. But yeah, we are ready for this. As aggregator, we will aggregate. For now, we aggregate like 50,000 of smart contracts on Ethereum mainnet. But we are ready to aggregate 1 million of smart contracts. Not everyone is ready. It's a matter of architecture. But yeah, we are ready. Almost.
Sorry, good question.
Yes.
So it was interesting for me when you said that you can determine is your kernel what is your leverage position, and also you learning when you apply for lawful studies. So what's interesting for me, like how you, it sounds like you know But you sacrifice DEXs, for instance, reliability to our users' income. So how can you be sure that there won't be DEX with like millions of PP, but what for $10 fails? What prevents me as a greedy user to come to transfer some money to some account, to leverage it, apply it to a lot of positions, and leak this account? Because this says that it will earn rewards even if you don't really provide a lot. That's something more policy.
Yeah, I would say I did not say that you are like faking those liquidity. It's not being fake. I said that in general, utility is being underutilized. Your liquidity in AMMs is participating fully in defining the price according to your balance, but it's being utilized really poorly. And if you would use the same amounts being utilized poorly in multiple places, you could achieve better utilization. You could achieve 100% utilization by placing your liquidity in like 5, 10 different shared positions, different combinations of positions. This would mean that your liquidity would actually work for you. What you are talking about is that some users could probably try fooling the takers. The taker can do like an infinite swaps. Yeah, that's a matter of all this infrastructure to handle it properly. For example, we in DEX aggregation, we understand the real balances of the users and how much they're offering virtually, and we take this into account. This thing is very similar to what we have with limit orders nowadays. You can see, like, you could put any amounts of limit orders, but your balances are not actually covering this. And this is not a problem. And this will not be a problem for Aqua.
Yes. So that another question. If I'm an AMM developer, does this mean that I need to create my own UI, or is it like plugged into the money distribution? So your basically interface asks where the AMM is about the best rate. So
yeah, good question. For now, I'm talking only about architectures and protocols. So I'm talking about possibility for developers to build their own AMM as a protocol which could interact with LP wallets through Aqua, permissionless LPs, permissionless AMMs, permissionless DeFi. But yeah, you're asking about frontends. So yeah, those AMMs could be separate projects. They could offer their own frontends. Maybe we would end up having like a marketplace of widgets for those strategies in 1inch. Maybe we would do this, but this would also depend on our requirements for audits, for other things, because if someone would bring us AMM with like 5,000 lines of code and said, oh, please list it on your website, oh, I'm not sure. How much audits you have, like 2 per 5,000 lines of code? Wow, that's pretty risky, I would say. Number of audits only makes sense with a number of lines of the code, because for now in Aqua, we have 100 lines of code in Solidity. And yeah, we are going to make 10 audits, probably more. And this will be the most audited smart contract per line. Yeah. So yeah, that's a difficult question. Maybe we would do something like that, maybe not. I mean, we're just providing the tool which could be much more convenient to compete nowadays. Because TVL competition is actually like killing all competition. It's super hard. Getting shared access to liquidity is much more easier. More questions, guys?
So this lock currently varies opposability. So in this
Probably key assertions.
Yeah.
But ideal, are there hooks? Sorry.
Oh yeah.
Ways to
Describing another highlights, and do you expect that flashing to be different strategies in terms of copper policies?
Yeah, we have hooks in SwapVM. I will open something like a slide related to SwapVM, but it does not have anything about hooks here. Yeah, for Maker, we have 4 hooks. It's pre-transfer in, post-transfer in, pre-transfer out, post-transfer out. It's also callbacks for the taker. Taker could opt in for pre-transfer in callback, pre-transfer out callback. Yeah, And users could also receive those hooks calls not on their address, but on any other smart contract. So we could have some smart contracts implementing sublogic, users could approve to them, and which would serve specific needs of the users. For example, users will be able to set up position with the A tokens of Aave, and they will be able to set up hooks to some smart contract, help them to unwrap before funds are being leaving their wallet, and wrap when funds will come to their wallet. But we would not advise people to do it like that, because we can do this simple thing as wrapping and unwrapping on aggregator level. Because when we will get A tokens from tens or hundreds of positions, we would rather unwrap and wrap them as a one batch, not individually. But yeah, you are free to develop any custom logic for sure. It will be like taker's responsibility and infrastructure responsibility of DEXs, of solvers to understand how to deal with it, is it working on that or not. But one of the cool things that we have simulator in Aqua. Simulator is a simple function with like few lines of code. You could ask Aqua to delegate call to arbitrary smart contract to perform any logic you want. Want to transfer assets from any LP to check it out if it's working or not? Yeah, do it. But at the end of this arbitrary delegate call, Aqua would revert with all the information collected from this arbitrary delegate call. So you could like really debug what's going to happen. Because if someone is providing liquidity, it actually does not mean it's not locked. Maybe their USDT are like blacklisted. You don't know. You can try it out with a simulator. Yes?
What are the biggest barriers to adoption of your technology?
Yeah, as one smart guy said to me on my previous interviews to CP0X, that there are two things. Protocol thing, technology one, and the product thing for users, for liquidity providers. And I answered actually that there are three things. And one of the missed things here is economical thing. If something makes economical sense, it will be adopted. I see huge economical benefit for liquidity providers. They could get the efficiency of professional market makers within self-custody strategies being run by AMMs. Because that's actually what professional market makers do to increase their capital efficiency. But yeah, you can give them your money, so they would probably earn for you. But this is a custody solution. You would not like that. You are here because you want your money to work for you in self-custody manner. So yeah, we are bringing power of private market makers efficiency to LP, AMM enjoyers like you.
But we love you so much. We want to speak like 2 hours and
Okay.
happy to, but we have, I think, like 7 more speakers.
Okay, sorry.
Well, will you be around like for 10?
Yeah, I will.
So, well, I don't want people to weak the space just because of you, no? So, I mean, I mean, like, can I just like ask all of the questions somewhere there?
Yeah, I can answer later, and yeah, still have 10 minutes, but yeah, I will be available online. I know how to use internet, yeah.
Yeah.
Okay.
Wait, thank you so much. Yeah.
Thank you.